Good morning, good afternoon, whatever the case may be. This is Tony Dubiel coming at you with another short demonstration today focused on the Cisco Container Platform. We're not going to go into an overview of Cisco Container Platform in any great detail, and it's not going to be an exhaustive list of capabilities and functions and so on. What we will focus on today is configuring the Cisco Container Platform as code and using Ansible as the coding tool. So if you would like to follow along during or after this video, you can simply go to developer.cisco.com, and from the main landing page, you can navigate to Sandbox. And from Sandbox, you can find the Cisco Container Platform version 3.1, and you can certainly reserve this sandbox from anywhere from 1 day up to 5 days. And if you'd like to, you can clone down my Ansible playbooks and other code from this repository here at the bottom of the link here. And you can follow along and configure your container platform as code. So without further ado, let's go ahead and jump into this demonstration. Okay, so here's the main graphical user interface for the Cisco container platform. Um, Typically, we would need to use this UI in order to provision our Kubernetes clusters. But before we do that, we have to set some parameters. So you can see here that we have infrastructure providers. Currently, there's two infrastructure provider options. We can configure a Kubernetes cluster on a vSphere, a VMware environment, on UCS, or even better, on Hyperflex. And there's some advantages there from a storage driver perspective and durability and multi-site, as well as access to GPUs and a bunch of other great value in Hyperflex that we can talk about on another overview. And then our second option is AWS. So in Amazon Cloud, we can actually integrate our Cisco container platform to the EKS service, the Elastic Kubernetes service in AWS, and that provides us a single touch point for programmability between on-prem and public cloud in AWS. Now, if we were to set up a new cluster, we would need to provision it through the UI, through here, and then fill out several forms. And as you can see, there's subsequent forms through next, and so on and so forth, and many steps here that we would need to populate specific information for the parameters that would take some level of effort and time. So that's not what we want to do today. So today we want to skip out on this, and we want to use the APIs. So the APIs allows us to avoid a bazillion different mouse clicks, as well as having code, machine readable definition files that we can commit into our repository as code for source control, and we can manage our changes to the Kubernetes environment in an infrastructure as code type of way where we incorporate DevOps best practices. So that's what we want to do. So how do we do that? How do we understand the APIs? Where do we get started? Well, there is a tool called Swagger, and Swagger is an open API tool that allows us to document our products, but more importantly, interact with the APIs so we can become familiar with them and understand what API calls will we need in order to create a Python script or library, or possibly in Ansible creating a custom module where we can leverage Ansible as an abstraction to the API calls. So the first step to that, and what I'm going to show you today, is creating an Ansible playbook, interacting directly with the APIs. The next step in my goal moving forward would be to convert those API calls into a custom module where we are just using playbooks on the front end with YAML, and all of the API magic is kind of abstracted and behind the scenes and in Python. So today, Ansible as the API client, if you will. So how do we understand these APIs? So if we look here on Swagger, we can expand operations. We want to start here with this first one, system login, so that we can log into the environment. The good news is in the sandbox, all of the credentials are the same regardless the pod that you're assigned. So you can follow along with me later as you reserve a sandbox in DevNet on developer.cisco.com, and these same credentials will work for you as well. So admin and Cisco 123 will allow you to log into the Cisco container platform. So if you add those credentials in, then you can click try it out. And what you want to see here is a 200 response coming back, which is good. This means that you're logged in. So that way, if I'd like to test out any subsequent API calls for a period of time, and I believe that period of time is around 10 or 12 minutes before you would eventually need to log back in. You can go ahead and try out additional API calls to see how they work. So here's liveliness and health of the system, and we can see we received a 200 OK, which is good. And we can see some additional response headers here, some information that we can glean from the API configurations. So here's where we can receive information from all the clusters. Currently in your sandbox, or when you first reserve the sandbox, there is a cluster in there just to give you something to play around with. So if you expand again, you notice that there's all this placeholder information. So these are just default placeholder strings that they put in here. But in our actual configuration, we have some parameters that we'll see some specific values that we will see come back. Right, and here's what we have in here is one cluster. It has a UUID that we can use to point to the specific cluster. We can see the name of the cluster. It's Sandbox Demo Cluster. And if we were to look back here, we can go back. Let me get out of this screen. Right, and we can see that this cluster was already pre-existing in our sandbox. All right, all right, all right. Let's take a look at the vCenter environment with our vSphere version 6.5. We can see some virtual machines already running. First, we'll take a look at CCP control. As you notice, there is a single master. This is the master Kubernetes for the control plane of our Cisco container platform. So this specific master normally would be deployed or will be deployed as a cluster of at least 3 master nodes for the control plane of our platform. However, this being a lab, then we can get by with a single master. You'll also notice that we have 3 worker nodes. These worker nodes are focused on the management workloads that we will also run as pods and as containers in our control plane. And this is actually a part of the install and curate it. So these management capabilities are part of the turnkey aspect of the Cisco Container Platform. So the benefit here is that we curate a installation of Prometheus, which gives you a tool to look at the health and status of your tenant container platform, or your tenant clusters that you're going to deploy. And it also provides you with a Grafana dashboard so that you have a mechanism built in for visibility to visualize, from graphs, the status of your Kubernetes clusters. There's also an elk stack for the logging. And these tools are baked into the product as a convenience so that you as an end user do not have to manage the lifecycle management of these tools or your container control plane. So that's another part of the value proposition is that when we take away the complexity of the lifecycle management being the updates and upgrades of Kubernetes, that is done as part of a feature of the platform. And then from a tenant perspective, we have Sandbox Demo Cluster that we looked at earlier. In this case, again, we only have a single master because it's a lab. And then we've deployed 2 worker nodes. The worker nodes are VMs that are used by Kubernetes in that cluster for the tenant that is deployed for you as a user to deploy your own containers into pods. So these are your application workloads where workloads here are primarily, they are focused on management capabilities. So we have a Kubernetes cluster, then we build additional tenant clusters, and then that's what we're going to do is show you how easy it is to build and manage clusters from the API using the Cisco Container Platform as code versus the GUI. And again, we'll circle back to ESXi and vCenter so that we can see progress as we build our components. Okay, we're 10 minutes into this video. Where's the code? Well, here's the code. This right here is ccp.yaml. Again, on the that slide, I have the link to where you can clone down the repository that includes these files. So this is a YAML playbook file, and I'm just going to run through how we would use this and some of the code and what it means real quick before we actually invoke this code and then render a new cluster in our sandbox. So to start off, I have a task here that says parse CSV and make vars file. So we'll take a look at this Python file that we're actually going to invoke from our Ansible playbook, which is going to take a look at a CSV file, a comma separated value file that includes variables for our code. So what I did was I wanted to split out some of the parameters, the variables, the elements that are configurable items, just to show how we could potentially create an abstraction and make that available to others that may not understand the GUI or even any of the aspects of this code, but they can populate the spreadsheet for us. So that way we can create our naming conventions and other constructs and have those available that are able to make shareable to those who can uh, take that spreadsheet, and then we can launch, simply a playbook and make it much simpler to configure the container environment. So maybe a DevOps team or developers that want access to these resources don't have to know, all the low-level details. So we can see that we're using localhost, which means we're going to originate a REST API call, in this case from my laptop, as opposed to using Ansible with SSH to connect remotely to a device like a server or a router or a switch. In this case, we're using the REST API calls of the Cisco Container Platform. So the APIs that are available for the platform are running in that control plane. So in that master and worker nodes, I mentioned some of the management tools. We also have the API engine is running as workloads on that cluster in the control plane, and that is the API that we access not only from our code but also from the GUI. The GUI is actually talking behind the scenes to those APIs. Those APIs are written in Golang, and it's running as an application on that control plane. So that allows us to leverage the APIs to pass through configurations, directly into our Kubernetes uh, cluster environment. Now, another thing that we've done here is created some local variables. So we can pull in variables from other files. So in this case, we're going to take in a spreadsheet, a CSV file, and we are going to convert it to a dictionary in a YAML file that we can use for inputting variables into our Ansible playbook. So we'll table that for a second, and then we'll hone in here on these local variables that I've actually added to this playbook. So what I'm doing here is I'm saying that workers is actually a value of 1. So 1 is an integer here, and we can modify that variable. But for our initial cluster, we're going to build it with a single worker node, and then I'm going to leverage an additional playbook to scale up. So perhaps we, create an application stack in Kubernetes with replicas, and maybe as we need more capacity, we scale up the replicas from a container perspective. But at some point, that virtual machine or virtual machines as worker nodes, we're going to run out of space potentially. So we need, in this case, a way through code that we can leverage to expand and create more capacity, more additional worker nodes that we can spin up using the APIs. So another thing we have here is passwords. So our environment variables are in a passwords.yaml file. That's where we have user admin and then the capital C Cisco 123 credentials that we looked at earlier. We've included them into this YAML file to use as variables for our playbook. In reality, we should, best practice for security, we should encrypt this file using Ansible Vault, but since this is just a lab, we have neglected to do that. And then we also have the as I mentioned earlier, we bring in that cluster.csv file that's been converted into a dictionary, into a YAML file that we can input into our Ansible playbook. So there's a couple of things here, just real quick, that you need to understand is that through the Ansible playbook, we need to log in and we need to create a token. And then we're going to use that token in our API calls. So the first step here is, and I'm using curl within my Ansible playbook. So I can either use curl or better use the, an option that's better would be to use the URL module to interact with the REST APIs from our Ansible playbook. So I've done both just to give you kind of a feel of both. So I started with a curl command, a post, and then in my header, I'm going to accept JSON back, which is important. So that's a little bit easier to read than XML. And I'm sending my username and password credentials to this inventory host name is actually in that password file as well as part of the environment variables, the IP address of the Cisco Container Platform. And again, since this is just a sandbox pod, that IP is the same for every pod. How do we do that? You VPN into these pods, and they've maintained the same IP addressing in each one of these pods. The difference is that you're connecting through a separate VPN connection into a separate pod that's been configured identically as the other pods. So all these other local IP addressing schemes are the same in these sandboxes. So once we receive our payload back, we're going to register that payload and we're going to call it token. And then I print token out just so we can see it. So this is only for our purposes to see it on the screen. How do we get to the token? So we register all of the JSON payload coming back from our post from the CCP server. And then we are going to parse in that dictionary, that JSON payload, to the specific line that includes the token. So we grab the token, and I had to actually look at the entire uh, payload and find where the token was, and then I'm effectively navigating to it using parsing. So we print it out just so we can see it. And then what we want to do is we want to configure a new cluster. So when we configure a new cluster, it's a post. And then this time, in this particular example, I'm using the URI module with a URL command, right? And the method is post, so we are creating a configuration. And in the body, we have this JSON dictionary. And you know it's JSON because we have the curly braces, and then we have key values. Now, some of these values are hard coded, right? And that was only because there was already items that were in there. But some of these items or these elements are configurable. So I went ahead and created some variables. And these variables are included in the CSV file that we'll take a look at here in a second. So you notice item.name. So name is a variable. And item means that we can loop through that information that we've imported in from the converted CSV file into that dictionary that we've modified through the Python script. We created a dictionary in a YAML file. So if we had more than one row, meaning if we're building more than one container cluster, we can do that because we can iterate through each row. So at the top of the file, there's the columns, which are the names of the variables, and then the next row it would be the first row of variables. And then if we had a second row, then we would iterate through that. And the iterator is item. So I'm going to go ahead and scroll down, and you can see there's some variables, some hard-coded items. That's not as important here. But these are all mandatory parameters that we need to send in our post when creating a new cluster. So here is where we make our way down, and you can see this loop command. So we take the input that comes in from that file, and the actual dictionary is called raw data. So how do we get that name? You'll see that in the Python file, in where we configured the raw data and how it's rendered into the from the Python file that we use as variables into our Ansible playbook, which is something that I want you to understand. It's pretty useful when I actually use this CSV option quite frequently to make it easy to share with others, and they can just add variables and run the scripts and not really need to do too much low-level interaction with the playbooks. So, and then at the end, we have a pause of 5 minutes. That gives us time to build the cluster and make sure that it is running from the playbook so that we have a success. We won't have to wait that long because I'm going to pause the video there. And we can see this XAuth token. Again, this is, if you recall from earlier, this is the parsing that I did to navigate to the token, and we are using that token as part of our post. So this is a header, HTTP header in that post API request that's coming in to create a new cluster. And we're able to do that because we are all authenticated and leveraging this token. So we just add this line to every one of our API calls, and then we are okay. So let's go ahead and look at the Python file real quick. And this is what we did here is it's a Python file that we actually invoke from our Ansible playbook. We just have to have, Python installed, which we need to anyway because Ansible is actually written in Python and it's a requirement to run Ansible. And then from Python, we need these following modules. So if they don't exist, we would have needed to import them or actually pip install them, and then subsequently we can import them into our Python file. So we're importing CSV, which allows us to parse CSV spreadsheets, and then import sys, which allows us to use some of the commands from the operating system, and then import YAML allows us to take the CSV file and convert it to a dictionary that we can save as a YAML file. So from the code perspective, we're really just looping through that CSV file using this dictionary reader. And then for every row in the reader, and again, in our CSV file that we're going to look at in a second, I only have a single row, but if we had more than one, we would just keep appending those rows, and then we can iterate through them in our Ansible playbook. So we can build more than one, variable and just iterate through rows if we'd like to. And then we're going to open up the YAML file as an output, and then we're going to name that dictionary raw data. So that's important. That's what we keyed in to from our Ansible playbook that we looked at a second ago. So there's several other YAML files that we're going to see too. We're going to delete our cluster as a cleanup, and we're also going to scale up and scale down. So I'm just going to take you into those quickly so that you understand what's happening in each one of these playbooks. But the value here is that we can run these playbooks and very easily manage our cluster after we build it to add additional capabilities or capacity. So it's very similar to the other one, and I'm just going to work my way down. And you can see scale up is 2. So in the initial cluster, we're only adding a single worker node, and effectively what this playbook is going to do is add an additional worker node. And we could increase that number. Just keep in mind that in your sandbox environment, the VMware capacity, the pods are kind of like nested virtualization, so you may not be able to scale up too many of these before it kind of affects the pod itself. But you could probably scale up maybe up to 4 or something, and it should be fine. And then we already talked about the other part, getting the token, so on and so forth. We've just repeated some of the same code. And then here's what's different here. So in this method, I'm using a patch as opposed to a post. So with an API call, I can use a patch, if available, to change a single configuration. So if you recall in the post, we had quite a bit of parameters in JSON that were required that we needed to either have a static item or element defined, or we could use our variables. We have a very simple body in this patch where all we're doing is we're modifying the size. So size is an argument that we can create a variable for. In this case, scale up, which was up, let me scroll up here real quick. Right here, scale up is at 2. That's an integer. So that just says that we're going to increase the size to 2. right? And it's JSON format. Pretty much everything is the same. We have to use that same token, so we still have this parsing here, and so on and so forth. We just pause for a minute here just to give it time. The scale up is actually fairly efficient, so it shouldn't take more than a minute, hopefully, to bring up that VM. The initial cluster is a little bit longer because the master nodes take quite a bit of time. But again, we'll skip through that. So we can, very easily clean up our environment and free up those resources. So in delete, I'm just going to scroll down to the main code. Everything else is pretty much the same. You probably are noticing these patterns. Delete cluster. So delete is actually its own method, right? So in this particular case, what is important here is that we delete the correct cluster, because we can have more than, we can have several clusters configured in our CCP. So this particular parsing here is to the UUID of our cluster that we built. So we want to make sure that we're using either through variable or hard-coded the ID of the cluster we want to delete. So that's what we're doing. And we're deleting our cluster that we're going to build, not the initial cluster that was already in there or any other cluster that we build. We want to be more specific in this URI, pointing to the actual cluster. So these would be like the optional filters that we can become more specific. All right, so without further ado, let's go ahead and build our cluster. Let's run our playbook. All right, so while that's doing that, let's go ahead and take a look at what's going on in our cluster. And we can see that it's provisioning the nodes, so we might as well take a look at our VMware environment. We can see that it's starting to bring up the cluster master. Now you can see it's working on the worker node. Here's the CCP tenant image that it's using, that's cloning from, and here's the worker node that's in progress. Hey, look, we're done. API cluster, and it's ready. What can we do next? So we click on the cluster here. We can see some information on the cluster. Again, we only have a single cluster worker, so we're going to increase that. But before we do that, let's talk about some of the other lifecycle options that we have available to us through the CCC platform. And then we also have the ability to leverage APIs and access to some of these other tools. So here's the Kubernetes dashboard. I mentioned because we don't have credentials to access the Linux VMs directly in this particular lab, they've locked that down. We don't know the password so that we can send our public keys directly from our Mac laptops or Windows laptops. But we can use the Kubernetes dashboard. So what we're going to want to do is download this key to our laptop and just save it. And then we can open up the Kubernetes dashboard. Just have to accept this certificate risk. And then we're going to click here and we're going to, file. All right, so we need to find that file. We just download it right here, kubeconfig, sign in. And now we have access to the tenant cluster that we built. So if we look at nodes, we can see our worker and our master. And then we have other information in here that we can use from the GUI. So in order to create an application stack, we'll click this plus sign to create. Okay, let's paste in our YAML from app YAML. So if we go into here, we grab all this. Make sure we have it all. Yep, copy. So we'll run our manifest through the GUI, paste it in, upload it. All right, so it's going to build the containers that represent the backend SQL database, the front end web server, Wildfly, and then there's also some some services that it's going to bring up. I'm going to go ahead and grab this port, and we'll couple that to the external page IP address. All right, so there's the port, and then we'll figure out, while this is setting everything up, we'll take a look at the node. Right, and then we've got the worker node where we run these workloads. I need to find its IP address. External IP is this that we can access through the VPN connection. Bring that in. And if everything's finished spinning up, it should. There we go. So we have a web page. So we have a web page and we have a back end. I think we can see like documentation. That's all running locally from the SQL database, MySQL database. But what if we would like to increase the capacity? So that is part of this, the replica sets, or the replica controller, I'm sorry. And then we can modify from here. So the thing that we want to key in to is replicas. So right now we're only running a single container pod of that front end. So if we wanted to increase it to 2 or more, we could do that from here. Right, so now it's going to bring up 2 of those. It's spinning up another pod. Right, so we've got 2 of those, but all of this is running on our worker node. So at some point, we could run out of capacity. Hence, the reason to be able to scale up on the worker node side of things. All right. Let's take a look at what's going on in the cluster. Give that a refresh. We can see that we're provisioning another worker node. If we take a look at Kubernetes and we go to nodes up here. Okay, if we take a look at Kubernetes nodes, okay, we can see that it's not completed yet, so we don't have our node available. So let's take a look at what's going on in vSphere. And we can see that we're still building from a cloned image that additional worker node right here, and that's its ID. So we'll come back to this in a second. Okay, easy peasy. We now have 2 worker nodes that we scaled up to. Okay, now let's return capacity back to the system and take advantage of Cisco Container Platform's ability to make all of the environment very disposable and reusable. We can go ahead and easily delete and clean up this cluster that we just built from code. So go back to the code, and we'll run CCP delete. Okay, take a look at if it's invoked the process, and we should render one of the second cluster should be removed soon. As you can see, it has removed our cluster, our second cluster that we built. And we can take a look at vSphere, and we can glean that we only have our CCP control, and that original sandbox demo is all that remains in our vCenter. Thanks for tuning in once again for another Net DevOps related / infrastructure as code related demo featuring the Cisco Container Platform.